All right, ladies and gentlemen, first type of exercise here that we're going to do is determining concavity and inflection points algebraically. So the main idea on these is that you want to first take the second derivative and equal it to 0. And then you want to make a sign chart with the second derivative. So what I would do here is I would take the first derivative first. So I have 4 times 1/2, which is equal to 2x cubed. And then I have 3x squared. And then I'm just going to take the second derivative now. So this is going to be 6x squared plus 6x equals to 0. And I can just pull out a 6x. So I have 6x times x plus 1 equals 0. So this means that 6x equals 0 and x plus 1 equals 0. So that's x equals to minus 1. Now I want to try a sign chart with this. So I'm actually just going to do a f double prime. And I'm going to include a -1 and a 0. And I'm going to see what happens with my concavity. So I'm just going to kind of write on the side here that my f double prime that I figured out was equal to 6x squared plus 6x. And I'm just going to go use my calculator feature. And that is perfectly fine to do. So, in fact, I even like to, anytime that I see an x squared, I just put parentheses where the x goes. And I put the exponent. And then I put parentheses again where there's the x. And then that way I can just plug in my y value. So maybe I try like -2. So I even like to put what I like to try. So here I tried a -2. Maybe I'll try like a -0.5. And maybe I'll try a 1. And I'll see, what's going on with these. So I have a -2. And I'm just going to plug this in. And when I plug in -2, I get a positive 12. So that is a positive number. So that means from -infinity to -1, we are concave up. And what I'm looking for is the change in the sign chart. So now I'm going to try, -0.5. And I do go to negative concavity, concave down when that occurs. And then I'm going to try like a +1. And I'm going to predict that that's going to be a positive number. And I'm just going to put a positive sign on that. So it turns out that these are our inflection points. And I can just put like -1, 0, and it will get me nice and professional with that set notation. All right, when you kind of submit your solution, you can kind of see their rationale as well and see how they made a sign chart. And it even kind of gives you some numbers to check. So that way, if you do get it wrong, you can see how they arrived at the sign chart, and you may even want to try and use the calculator feature as well if you do get a problem run on this set of skills. The other flavor of question that you're going to get is determining the interval for which it is concave down. It is the same procedure here. So what we're looking for is that f double prime of x is negative or less than 0. That's what we're looking for. So it would be nice to know first, when the concavity, when f double prime of x is equal to 0. So I'm just going to write down my first derivative. So let's see, that's going to be x to the 4th plus 4x to the cubed. And then I'm going to write my second derivative. So that's going to be 4x cubed plus 12x squared. And I'm going to suggest that you pull out a GCF at this point. So let's see, there's a 4 and an x squared. So when I do that, I get 4x squared times x plus 3. So I get x equals 0 and x equals to minus 3. I'm going to try a sign chart now. Note that when you do make a sign chart, you want to communicate that you are looking at the second derivative. So I'm going to have a 0, actually a negative 3 and a 0. We want to kind of go in order. So maybe I'll try negative 1, 1, and like a negative 5 maybe. And I kind of put in parentheses that these were kind of the numbers that we tried. So I'm just going to go to my calculator feature and try these numbers out. So I'm going to use the equation 4x cubed. So I'm going to do 4 times negative 5 to the cubed plus 12 times negative 5 squared. So that's going to be a negative number. That's definitely concave down at that point. So then I'm going to try like negative 1 and see what happens. So when I put in negative 1, I get a positive concavity. And then I'm just going to try 1 as well. And that's going to be a positive concavity as well. Now, one thing of note, if I were asking for when it is concave up, it is continuing to be concave up. And technically speaking, 0 is not an inflection point because you're not changing signs in concavity. So that's one thing that you'll want to, kind of be careful about in these solutions. So now I'm just going to kind of put in set notation here, negative infinity. It's kind of like your interval notation to negative 3. And I'll just submit, and we are good.